Good morning, class. Today I am going to start a new lesson, that is lesson number 2, chemical bonding. Chemical bonding. Everything in this world wants to stability. So the case with atoms, for atoms, stability means having the electron. What is stability? Stability means having the electron arrangement of an inert gas, that is octet in its outermost shells. Helium has 2 electrons. Helium, another element, that is helium, have how many electrons? 2 electrons in its outermost shell, or valence shell. So it makes what? It makes a duplet. While other inert gases, that is, what are the inert gases? Neon, argon, krypton and xenon, radon, have 8 electrons. So 8 electron, 2 electron means duplet, 2 electrons means they form duplet, while 8 electron means octet. In their outermost cell. Outermost cell. So it is found that the electron with their complete outermost shell do not react. So these elements, neon, argon, krypton, xenon and radon, they do not react, and the shell do not react or are less reactive. So these, they do not react. They do not react or least reactive. Helium also, they do not react, and everything in this world wants stability. Stability means having electron arrangement of inert gases. So we know that an atom An atom is electrically natural neutral electrically neutral. The number of positivity charged particles that is proton is positively charged particle, that is proton, are equal to the number of negatively charged particles. That is electron. Electrons are negatively charged particles while protons are positively charged particles. These things you know earlier also. Electrons. So in every atoms, this is important point, the number of positively charged particles, that is proton, are equal to the number of negatively charged particles, that is electrons, and they are electrically neutral. Atoms are electrically neutral. Every atom tries to attain a stable electronic configuration. Every atom tries to attain the stable electronic configuration. They tries the stable electronic configuration of nearest, the atom which is nearest inert gas, that is what it is, 8 electrons in the valence shell. This is valence shell, last outermost electron. One important point, that is exception is there, except what is the exception? Helium, because they make the duplet, na? So helium is the exception for that. Helium which is having two electrons in the valence shell. 2 electrons. I earlier said this is duplet. So how many electrons is there? 2 electrons. So 2 electrons in the valence shell. So we know that atoms are electrically neutral and every atom tried to attain a stable electronic configuration. So the atom attains the stable electronic, how it will be attained the stable electronic configuration. The next point is atom attains the stable electronic configuration by three types: either losing the electron, gaining, or sharing. Either losing the electron, gaining the electron, or sharing the electrons. Atom attain the stable electronic configuration by either losing the electron, the first one is losing, the second one is gaining, or sharing the electrons. The next point is ions. What are ions? Ions, when an atom loses or gain electrons, it gets converted to electrically charged particle called ions. So ions are also two types: cation. The first is cation. These things you have already read in class 6, 7, 8 also. When, what is cation? When an atom loses electrons, it gets converted to the positively charged particle. Positively charged particle. It is important. What is cation is important for your exam. And anion, the next one is anion. Ion is classified into types, two types, cation, and the another one is anion. Anion, just opposite to the cation. When an atom gains electron, when an atom gains electrons, it gets converted to negatively charged particle called an ion. Charged particle called an ion. So two type we have discussed here: ions are two types, cation and anion. Cation are positively charged particles while anion are negatively charged particles. And how anion converted? Anion, when an atom gain electron, it gets converted to the negatively charged particle. The electropositive elements. The next point is, which is very important, electropositive elements. Electropositive elements. The element which easily loses electron. The element which easily loses electron. Which easily lose electron. Electron and acquire positively positive charge are called electropositive element. Positive charge are called electropositive element. Electropositive elements. Here one thing must be remembered, that is, all metals are electropositive. What are the example? As for example, sodium is a metal, so it is also electropositive, Na1+. Potassium, it is electropositive. Calcium, 2 positive ion. Magnesium, 2 positive ion. And you know that what is the reason behind that? Why 1 positive ion of potassium or the sodium having 1 positive ion? Because they have only 1 electron, 1 valence electron. Aluminium 3+, etc. Now the next one is electronegative elements. Electropositive metals, all metals are electropositive. The next one is electronegative. Electronegative elements. The elements which easily gain. The elements which easily gain electrons. And acquire negative charge are called electronegative element. just opposite to the electropositive element, electronegative element. So here the electropositive, all the metals are electropositive, means the electronegative elements, guess what it is? All non-metals. Non-metals are electronegative. Non-metals are electronegative. Electronegative elements. Example, electronegative elements. Example is chlorine. Chlorine is a non-metal, 1 minus. Bromine, iodine, fluorine, oxygen, sulfur, nitrogen, etc. Ionic bond. Ionic bond. Types of bond. Ionic bond. In the chemical bonding, one of the important bond is ionic bond. The element which easily gain electron and acquire negatively charged is called electronegative element. Ionic bond, the bond formed as a result of transfer of electron. The bond formed as a result of transfer of electrons So what is ionic bond? Formed by a transfer of electron, important transfer of electron from outermost, from where? From outermost shell of a metal to the outermost shell of non-metal. Outermost shell of a metal to the outermost shell of a non-metal. Means ionic bond formed as a result of transfer of electron from outermost shell of metal to the outermost shell of non-metal. Means ionic bond is from metal to non-metal. Non-metal is called ionic bond, and it is also known as electrovalent bond. Ionic bond or electrovalent bond is same. Ionic bond or electrovalent. Ionic bonds are formed between metal and non-metal. We can say that the ionic bonds are formed between metal and non-metal. Metals and non-metals. Metals lose electron while non-metal gain electron. So the ionic bond metals lose electron and non-metal gain the electron. For example, sodium, and another is chlorine. Sodium is a metal. So what is the electronic configuration of a sodium? 2, 8, 1. Atomic number of a sodium is 11. Atomic number of a sodium is 11, and the atomic number of chlorine is 17. So the electronic configuration of sodium is 281, while the electronic configuration of chlorine is 2, 8 and 7. Here sodium, the outermost electron in a sodium is 1, and the chlorine is 7. 2 to 4 to 6 and 1. 7. So the valence electron is 1 here, here also 1. So the sodium, sodium, 1 electron will be minus. It will make a sodium positively charged, and the chlorine, 1 electron except Cl minus. So the bond between sodium and chlorine is electrostatic force of attraction, and it will be formed by the electrostatic, this is important, electrostatic force of attraction. As a result of transfer of electron, ion formed which held by the strong electrostatic force of attraction. What is the electrostatic force of attraction? The transfer of electrons are formed which is held by the strong force of attraction. It's called electrostatic force of attraction. The metal participating in ionic bond formed should be low ionization potential. So till today this much only. Next I will teach the electrovalency and another bond in the next lecture. Thank you.